So hello, good to see so many people here. Slight different way of doing things because of how my computer is set up. Zoom doesn't let me screen share. So what I'm doing is I am running my webcam, I'm running OBS into a virtual webcam and pointing Zoom to my webcam. Can everyone see it? Yeah, all good, all good? Wonderful. I got this working literally a minute ago. All right. So, as was mentioned earlier, we will be doing something out of the penetration with Kali or OSCP certificate. So I'm actually going for my exam for this in a couple of weeks' time, and I thought I would give one of the give a demo of one of the boxes that, if you go for this exam, will definitely be there. So if you would like to follow along, what you want to do is you want to go to Google and look up something called Brainpan from Vulnhub. Make sure to get Brainpan 1. These are other versions. Don't worry about it. This is the one we're doing today. You can either get Brainpan directly from here, or we have one on the CTFD, which actually has a flag in it. So yeah, when you download that, you should get an OVA file. Let's see if I can find it. Okay, I have 1 million downloads, so trust me, it's there. What you want to do from there is you want to go to VirtualBox. Here we go. And then you want to go File, Import, or just double click the OVA. Provided you have VirtualBox installed, or VMware even, it should automatically import. And then you want to start the VM. For me, I am not actually going to do this. I'm going to do it through KVM, so the Linux way of doing things, and just start up that way. Yeah, it takes a while to start. Yeah, that's if you get this screen, you're doing good. Now I'm going to switch over to my Kali instance, and I'm going to log in. I'm going to get my password wrong. I'm going to log in. Wonderful. And then one last thing I'll need for today is I'll need a Windows VM as well. You don't have to have the Windows VM. It very much isn't required, just because Wine exists, and you can do this very much through Wine. I'm doing it through Windows just because, man, I spent 2 hours setting this up. I want to use it. Literally my reasoning. Cool. So let's head to our Kali VM. And one thing you'll notice, actually, let's go back to Brainpan for a second. One thing you'll notice when you get Brainpan is a login screen. If you try and log in, no one actually gives you login credentials. This is because this is what's called a pwnable machine, meaning you're going to hack your way in, and there is 0 hand-holding. So let's cheat a little bit. What was the IP of this thing again? There we go, 7.3, wonderful. So, assuming you've got Brainpan working, assuming you've got Kali working, and assuming they're running on the same NAT, which if you're just running a default networking setup in VirtualBox or KVM, should be all fine. You should be in able to go into your curly box and just ping it. What was it, 7.3? Yeah. Cool. So, all right. So we've got this pretty much black box now. How do we go about working with this? I don't know how many of you have worked or have attempted to. Oh, what is going on? Yeah. I don't know if how many of you have actually tried to do like hack the box or just in general some sort of pen testing. But if you have, you would recognize Nmap. So Nmap, basically just an automated scanner, tells you what ports are open. And if we, okay. I've done a starter box code. Well, I mean, hack the box, you've done at least something. And you would have probably have done at least one Nmap scan if you've done that. So if we do an Nmap scan, we'll see that I may or may not have already set this up. So it has a very quick response. And we can see that 2 ports are open, the port 9999 and the port 10,000. If we actually go to use netcat, which is basically just a low-level TCP connection, and we go to have a look at what sort of what's running on the 9999, we can see a very familiar getup. We enter a password, and it says access denied. If we instead go for port 10,000, 10,000 not. Yeah, there we go. And then we try and just communicate somehow. That is not right. Hello. We can see that it responds with what very much looks like HTML. So go up to the web browser. Let's have a look at this. 122 point. By the way, whilst this is loading, is my screen capture okay? Is it flickering at all? I've had some problems with that before.
Yeah, it's flickering as usual, but it's fine.
Okay, well, apologies about that. Yeah, you see here that it is indeed a web server, and we get this lovely infographic about cybersecurity. Cool. Well, first thing we should do is view page source. Anything interesting? Not really. All right. What about some of what about from Maresh's intro to web? Just robots.txt. Not working either. Okay. Any ideas? Anyone? How to actually go about finding what's on this page? Maybe a tool? Maybe Debugger. Once this thing loads, Debugger is basically Debugger. It is basically just, you give it a list of words and it's gonna go brute forced, hard at it. Do you have this directory? Do you have this directory? Do you have this directory? Not exactly the quietest thing, but this isn't an actual engagement, so I don't care. 7.3. We go up to where is it called? User. Go to share. Scroll over. Word lists. Dirbuster. Medium, because apparently medium's the largest they have. And incorrectly input. Don't forget to do the port number. What did I do? What? I swear this worked in the test. All right, specify HTTP. Yeah. Cool. And almost immediately, we see bin exists. So let's pause that. Let's go check out what bin is. And we can see that bin has brainpan.exe. The name of the channel is Brainpan. I think we're going in the right direction. So if we go away from our Kali VM now, and we instead go, oh, that's back into the Kali VM, and we instead go to our Windows machine, and we get this, and again, given everything is on the same network, I should just be able to go 192.168. Go away, Firefox. 192.168.122.73/bin. And remember the port number. Apparently, I'm just terrible at remembering that today. Let's increase this. We get Brainpan, and since it's an exe, we could have also used file on it, but just guessing it's going to be a Windows box. So get Brainpan. Let's just put that on here for simplicity's sake. What? Oh, it's up there. Cool. And Brainpan is there. And cool. Now, if we actually try and run this, Windows is a bit too smart. I did not think of this. Crap.
More info.
What? Oh yeah, because that's a run anyway, doesn't it? Huzzah! Run anyway. Okay. So connecting to a WinSocket, blah, blah, blah. And we can see that it's binding to port 9999. Looks familiar. Maybe it's the thing that was working before. If we take another command prompt, oh god. Come on, come on, come on. Oh god. We take ipconfig 82, go back to Linux, and we connect to 82 now instead, because I haven't done anything with, because I've turned firewall just completely off, because Windows Defender is annoying when you're trying to do this stuff. We can see that we now have something on our Windows machine. Cool. Now let's actually get to exploiting this. So for majority of this, we will be working in, for the actual exploiting of this, we will be sending it, don't look at that, one moment.
It's not like this is recorded or anything.
This is fine. I am a professional and I've remembered to clear my terminals. We'll just put a black bar in there. Forget about it. Cool. So yeah, the exploiting will be in Linux, and the development, I guess you could say, will be in Windows. So back in Windows, we can shut this down. Oh yeah, there we go. We can see that I tried to do stuff. Yeah, back in Windows, we look at something called Immunity Debugger. You can just get this on, just Google Immunity Debugger. It'll ask for like your name, your organization. There is no validation on that. I literally just put fake.com and it worked. So do with that information as you will. One cool thing about Windows is you can take the exe, you can hover over Immunity Debugger's shortcut and just drop, and Immunity should launch with the, yeah, there we go. Should just launch it. Now, if you haven't seen any, if you haven't seen Immunity before, this can look very daunting. Just to break it down really quickly, these are your CPU registers. If you've done 1047, I think it is. That should look familiar from MIPS. This is, I think that's just the modules being loaded. Don't need to worry about that. That's the stack, and this is the actual code. So if we go up here and we press play, we can see that the exploit, the vulnerable program starts. And so then if we go back to Kali and we enter in the appropriate IP address, 122.173, no, 82, 9999. And we just do what we do in normal binary, and we just throw in, sorry, 1 second. Oh yeah, duh. Yep. So if we just import Python socket, we make a string, we connect to where we want to go, and then we send the string. And if this is 100, we run this exploit. I said we run this exploit. And we go back to our Windows. We can see that it has received 100 A's. And it hasn't really done anything. Fair enough. What if, being the little devils we are, we up this to 500? Run it again, go back to this, and it seems to be working just fine. Okay. Up to 1,000. Oh, 10,000, no. Up to 1,000, run it. Oh, that's not the right one. And we can see it received it, it printed it, but everything here has gone blank. The reason for that is because we've crashed the program, and we need to, we can see that the reason we crashed the program is because we overwrote the EIP register with 4141414141, so on and so forth. Cool. So very classic buffer overflow here. Okay. So then if we reverse, yes, whatever, and we play again, everything refreshes, go back to Kali, and then we use, then we can use something like Pwn Cyclic, or if you're like me and forgot to install Pwn Tools before starting this, you can use something called Pattern Create, which is a part of the Metasploit framework. And we can go to that using Metasploit framework, tools, exploit, pattern underscore create.rb. And then we give it the parameter -l and say we want, what did it crash before? A parameter, we give it 1,000. This creates the pattern. This creates a sequence of characters, which will be very unique, or will be unique no matter what section of it you're looking at, and meaning that we can use the sister program, pattern offset, later on to figure it out, what's happening when we actually crash the program. So if we take this, we copy this, we go into string equals, and we enter that. If we get rid of our little naive approach and we run the exploit again, did I forget to reset? Hello. Oh, when you reset, you have to play. That's what I'm doing wrong. Come on. There we go. There we go. So yeah, play that. Go back to Kali. There's a lot of switching. And then we run the exploit. Go back to the Windows machine. There we go. We see it crashed. And then we can see that it crashed with the EIP pointing to this string of letters and numbers. So if I drag that over to my other screen for a second, I can see that the EIP was pointing to 35724134. Take that, put that back into pattern offset. I think it's the -L parameter again, and run it. Nope, it's the -Q parameter. We see that there is an exact match at 524 characters into the sequence. So if we were to then, make one of these 524, and then string equals string also has /x11223344. Run that. I'm going to restart my program again. Make sure that it's working. It's working. And then I run the exploit. Bringing this back over here, we can see that it crashed at 44332211, which is exactly this address, but in reverse because Little India. Cool. So then, well, we know we can control the return address. How do we go about changing where it jumps to? Well, that's where this immunity debugger comes in really, really handy in particular, because it has something called, it has the ability to work with plugins. Let's just restart that for later. And the plugin we're going to use in this case is something called Rhona. Rhona is basically just a Python extension to, I think this is a fork of OllyDB or OllyDGB, Olly Debugger. And it's basically just a Python extension of that. So you can look at memory, you can look at memory protections, and so on. So if we do Rhona modules in this little box down here, we get this terminal looking window. I don't know, is the compression fine? Can you guys see this? Because I don't actually know how
It's a bit tiny.
It's a bit tiny? Okay. Is that working? That looks bigger, so I'm going to assume that worked. I don't know how big I can actually go with this, because Windows is being annoying. Anyway, basically, what you see is all the DLLs and all the EXEs and whatnot that have been set in this, or that are loaded into memory whilst this program is running. And we can see that it has these sections called rebase, safesesh, ASLR. You might recognize that. NXCompat, OSDLL. Basically, this is just memory protections and whether or not it's part of Windows. And one thing you'll notice is that all of these are true except for one. And all of these are true except, and it has, so this one doesn't have any memory protection, doesn't have ASLR, doesn't care about the stack being executable. This looks like a pretty good candidate to look for gadgets, so ROP gadgets. Those being little pieces of code that you can jump to in order to execute some functionality without necessarily knowing. Actually, no. They're gadgets you can jump to that are already in memory. You don't have to write shellcode to use them. That's a better explanation. Cool. So what we do there is we click, I believe. This is the part that I always forget. Yep. So I think it's Mona. Then we can search within this executable section. We can search for a particular opcode or. Oh, that's right. I forgot to actually get the opcode. I'm an idiot. Yeah. So we can go in here and using the Metasploit framework yet again, because one thing you'll notice doing OSCP is that OffSec really likes Metasploit. I mean, I know they made the entire, an entire course dedicated to it, but come on, man. Give some more people some love. If we go into NASM, this thing called NASM shell, put that up a bit. And then we write in, I think it's jump ESP. We should get back, there we go. We should get back a hexadecimal sequence, which is what the CPU sees and thinks of jump ESP. So FFE4. All right. Going back into this because I know for a fact that they're running the same architecture, so I can use that. I use the command mona find, and then I go, I look for a particular sequence, /x, ff /x e4, and then I give it which module I want to look for this sequence in. In this case, it is brainpan.exe. And as we can see, that it has found one total result at this address. So that's 311712F3. Wonderful. Oh, that's not what I wanted to do. Oh God. Wonderful. Going back into our exploit, we know that the return address that we want then will be at remembering to adjust for Little Indian. That is F3 12 1731. Cool. So that works. Yep. We go back in here, and then cool. And if we take that, put the in there. Okay. We do that. I think it's go to the next procedure. So what I'm currently trying to, there we go, search for command. Another way you can do it is just to go to jump ESP via the search for section, go to command, and then type in jump ESP. One bad thing about that though is that it will, by default, Immunity Debugger only searches in executable memory. The reason I searched for it in Mona down here was because Mona just searched in general where is it in memory. Cool. So we know that that is where the jump ESP instruction is. So we can go here and we can go to breakpoint, toggle a breakpoint at this location, and now we know our exploit is working if the program hits this breakpoint. Cool. And then just double check. I haven't got it loaded, so let's play it. Go back here. Cool. Let's quit Nasm shell. Clear that out. We run the exploit again. Oh God, what's happening? Go back. We can see that it's copied, and we can see that it's kind of hard to show you that it's broken, but it's at a breakpoint. We can step one, or we can, which is the continue? I think that one's the continue. And if we do continue, we'll see that it pretty much just breaks. Come on. Copied. Live demos are always fun. Oh, I forgot to add the return. I'm an idiot. Cool. String equals string plus return address. Always put the actual exploit in the payload when you're doing it. Run it again. Come on. It's okay. This is not like me. Let's restart this. Play it. Got the breakpoint in there. Going to play it. There we go. We go back here. Run the exploit. Come back here. We see that it copied the 524 bytes and the return address, which is here. And then we can see that the current EIP is a very familiar function. It's the jump ESP. So we've hit the breakpoint. We have actually hit the breakpoint this time, and we can jump over. We can step over, and we can see what happens. And it ends up crashing because, well, we don't actually have any payload here. But good news, we are actually controlling code flow now. So now we just need a payload. And if you've ever done, has anyone besides Mariusz done any shell coding before? Yeah, you've never really got it to work. Okay. How have you been doing it? Have you been trying to generate it yourself, or have you been just copying and pasting it from a website? This is what I'm curious about. Let's get zoom up so I can actually see, because it decided, you know what, I'm not going to work. All right. So what we're going to do now is we're actually going to be using something called MSF Venom. And this is a program which generates shellcode for you. So, so that is MSF Venom. Again, MSF, Metasploit. Oh, OffSec really likes Metasploit. That is, OffSec is just script kiddies. Let's be real. All right. So if we do MSF-L payloads, we can see all the payloads that MSF Venom is able to generate. And because I'm doing this on a virtual machine, it really likes to take a while. There we go. It can do all these wonderful payloads. We don't care about majority of these. The one we care about is going to be Windows slash reverse underscore shell underscore TCP. Just make sure that I've copied that right. Where is, wow, I have a lot of tabs open, Jesus Christ. Okay. You know what, let's just do that. Shell underscore reverse. There we go. Shell underscore reverse TCP. Yeah. So that is your shellcode. But that's a very generic shellcode. It's not actually going to do anything. What we want, because this particular payload is a reverse shell, we need to specify a few things for it to work. Specifically, we need to specify the local host, so that is our attacker's IP address. If we go over here and we go IPA, we can see that we are at 59. So put that in as 128.168.122.59. We specify the local port we're going to be listening on because we need to catch the reverse shell. And in this case, I'm going to be doing it on the port 4141. And then we can specify something called encoding. So you don't really need to worry about this in Linux payloads, just because Linux doesn't really have antivirus. But Windows definitely has antivirus. Windows actually has built-in with Windows Defender. So you need to be a little more sneaky with your shellcode. And that's why we use something I can never remember the name of. MSF Venom Encoding Shikai, I think it's called. Okay. There we go. Shinkata Ganai. However you pronounce that. All you need to know is that it makes your, it's at this, that is where the encoder is specified, or well, the encoder is located on disk, and you get it with the -e parameter. You probably don't need to use any other encoders. There are some other ones like XOR and whatnot, but this is the one that really will just, what's it called? This one is the one that will just get past everything, basically. Cool. And then we want to output it because we're making a Python exploit. We want to do -f Python for format Python. Let it run a bit. We're going to also start our listener off to the side here. So netcat-nvlp 4141. So that will listen on all interfaces on the port 4141. And this MSF Venom. There we go. We can see we've got quite a bit of shellcode here. We add it in. Save it, and then we add that immediately after return address. And so that way, this will be on top of the stack as soon as we hit the jump ESP instruction. We will jump to the top of the stack and we'll start executing this payload. So let's run it and see what happens. Run it. go back over to our Windows device to make sure it's hit the breakpoint. And no, it hasn't because I forgot to restart it. Yep, awaiting connections. Back to here. And we see a Windows sound. So we know that something's happened. And immunity debugger has warned us we've hit a breakpoint. So we continue going on from that breakpoint. We go back to Kali. And it didn't work. We should have got a command prompt here from the server. That evidently hasn't worked. So what's going on? Well, let's look at the stack when we, let's first off rerun the exploit so I can hit that breakpoint again. Come on. Yep. Get that lovely do-do-do. Hit the breakpoint. Look at the stack. It's really hard to show this because I'm using dual monitors and it's so much easier that way. But effectively what you'll see is if you compare the stack with what is actually in the code. Oh, well, I'll step one. Yeah. If you actually compare this with what's going on in the shellcode, you'll see that it goes really well to a point. The reason for that is this is using a vulnerable function called string copy, and string copy is meant to deal with strings. Strings signify the end of themselves with a hexadecimal 00, right? It's the terminating character. So that means if we have any 0x00 in here, which we do somewhere, more than likely in this mess of characters, we will have a 00 somewhere. It means that it just won't work. So luckily, some smarter people than I have thought of this. And in MSF Venom, you can do -- bad chars followed by whatever bad character you don't want to be in your payload. And you can simply do, actually, you don't even need to do bad chars. Oh, you don't even need to do bad chars. You can actually just do -b and then put in 0x00, rerun the shellcode. Take forever for it to load, because when is MSF Venom ever actually working? Oh, take that. Take that. Save it. Rerun the exploit. Remember that you again forgot to restart the program because you're an idiot. Have a heart attack as your cat brushes against your leg and is silent as a motherfucking ninja. Make sure it's actually working. There we go. Go back here. Run the Python exploit. Get that do-do-do-do. Hit the breakpoint and continue. Wow, that doesn't look good. Let's have a look. Did we get a shell? We still didn't get a shell. Damn it. Maybe there's something I neglected to say. Final thing is Windows isn't exactly like Linux. Up until now, if you've done any Linux exploitation of buffer overflows, you will have recognized this pretty much step by step. The debugger is different, and the way we reference things is slightly different in the debugger. But broad strokes, it's all the same. The only thing that has really been different is that encoder, remember? And that encoder isn't the only thing that, that encoder isn't just there, well, it is there for the antivirus. Basically, you need to pay attention to that encoder. That encoder has a few caveats to its use. There are always downsides to using it. And the downside in this case is that basically how the decoder works is that it's like a zip file. The shellcode gets into memory, it has to decode itself, and then it runs. Now that is really useful, except for when the decoding takes up more memory than the original encoding did, which is the case in this. So what we need to do is we need to introduce a knop slit. Now, in x86, you have 0x90, which is no operation. If that gets into the CPU just basically steps over to the next instruction. So if we put, say, 16 lots of a 16-byte long knop slit before the buffer, hopefully that should give us enough space to be able to exploit it. And I'm just going to go and put this on my second screen so you guys don't have to watch don't have to watch me keep switching. Yes, I want to restart. Run one more time. The server is up and running. We send the exploit. The exploit has been received, I believe. Come on, you can do it. Yep, the exploit has been received. We hear that bada bing. And then we run that. And now that we have actually gotten the enough room to decode the shellcode has decoded properly, it has run, and we have gotten a shell. And as we can see, this is the same, this is the desktop environment of my Windows machine. So I have successfully popped a shell on Windows. See, Brainpan, Firefox, Tools, same thing in Kali. There you go. All right. Wonderful. We've managed to get it on our lab machine, which is the same architecture and everything as the target machine. So theoretically, we could just exit this, kill the connection, run again, make this a little clearer, run this again, change this to a 7.3, which remember was the IP address of our Brainpan victim, and we run the exploit again. We can see we've got another shell, but it isn't Attica. It is the user Puck. And if we have a look at this, well, maybe something in this directory could be used on our CTFD server. So hopefully you guys have enjoyed that. That is a very basic Windows buffer overflow, but it is the buffer overflow that is guaranteed to be on the OSCP exam if you choose to take it. It's also like a 25-point machine, and you need 75 points to get the certificate. So you better know this if you're doing OSCP. Yeah. Does anyone have any questions? That's pretty much all I've got for now.
Just out of curiosity, how does one go about getting OSCP? Do you need to do a course for it? Do you just sit the exam, or do you have to enroll a whole course through them? Or
so it's a course. If I bring this over, you can literally just Google OSCP certification. First thing here, and there's a big enroll button up here. You have to enter your details and everything. Yes, I'm 18 and older, blah, 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 billing information. As an individual, it is a very expensive course, but I mean, it's the only real course you need if you want to do penetration testing. After this, you get, like after this page, it goes on to ask you, do you want, I think it's 30 days, 60 days, or 90 days of lab access? You can choose that. They have varying prices. Pretty much you sit the exam, you get you get access, you basically get a VPN file. Where's mine? You basically get a set of VPN creds. You get the textbook, which is what I showed earlier. And then you get a bunch of videos. And then you basically work through it at your own pace for however long the lab is. And after the labs are done, you have up to 90 days after your final lab date to sit the exam. And I finished my lab 2 months ago, so I should probably be doing the exam.
And how long is the exam, Daniel?
Oh, great question. Actually, that is a really good question. I don't know why you asked that in such a yes, Miss Potts way. But anyway, the exam is 24 hours straight. So you have 24-hour access to the exam. If you're an insane person like me, you plan on doing it for 24 hours straight, or you can just do it and then have a sleep sometime in the middle of that, because after the 24-hour section, there is a 12-hour section of writing a report. So you actually, as part of the exam, you need to detail how you exploited the machines, and you need to say, okay, how would you fix this so if this was a real company, they don't get hacked? I'm not looking forward to that part.
What are the styles of questions on the exam? Are they mostly those kinds of questions, or is there also like XSS or SQL injection or whatever?
So do you mean questions as in like a written exam?
Oh no, like on the first part of the 24-hour one, is it mainly binary exploitation, that kind of stuff, or?
No, so to my understanding, and from a friend who's recently done it, there are, There are two 25-point machines, one of which is guaranteed to be a binary exploitation. And then the other 25-point machine is just a really hard machine. You don't know what it's going to be. Typically, it'll be like, here's a machine, find a vulnerable service, find a public exploit for it, or like maybe it's outdated, or maybe there are like admin creds somewhere left open, stuff like that. And then there are a 10-point machine, a 5-point machine, and a 20-point machine, which are, again, same thing, just varying difficulties. So, yeah. A lot of OSCP is surprisingly just finding the public exploit and hitting run. I don't know if that's how the exam works, but that's definitely how the labs worked.
How much experience do you think someone should have before going for the OSCP? Like, should you be decent to hack the box before doing it? Is that similar?
It is a very different experience, OSCP and Hack the Box. Like, you can definitely draw parallels because obviously they're inspired by the same. They're inspired by the same industry, right? But Hack the Box is a lot more gamified. It points you in a direction and you follow it, whereas OSCP is very much just drop you in, figure it out. Before doing my OSCP, or before doing the labs, I had done like the theory side of it, but so I knew the theory of buffer overflow. I knew the theory of XSS, but I never really did the practical. I had never actually like done, I think I had done 2 Hack the Box boxes before actually doing the labs. Really, it's just up to how much do you trust yourself to just figure it out. Something OSCP likes to use as their trademark is try harder. And if you've ever played Dark Souls, that will sound very familiar or very similar to something. Yeah. I don't know. You don't need a whole lot of experience. You just need to be somewhat familiar. They are very much a beginner course to try and teach you what you don't know.
All right, thanks.
Hope I didn't ramble there.
No, that's fine. That was useful.
Oh, sweet. I'm actually doing something with my life. Look at me, bum. Did anyone else have any other questions?
We might wrap it up there and put any questions in the workshop channel in the Discord.
Sure.
Make sure for everyone that did attend the workshop, if you could fill out the attendance, it helped us a lot for MSA. And if you fill out the survey link, then it helps us even more to help produce better workshops for you, especially for controlling whether we're doing this over Zoom or Twitch in the future. So yeah.
Cool. Thank you all for coming. That's all, folks.